Good afternoon, and welcome to another one of the afternoon security seminars. Today we have a set of topics, and instead of a single speaker, we are going to have the benefit of three speakers, members of the security team at Facebook. Mark, For, and Tim will present a set of topics to you about security, and Mark is an alumnus of the program, the precursor to the CERIAS program, the Coast Laboratory, from here at Purdue University, and is an example of what happens, well, maybe not an example, but a warning to others, and one that we're happy is here to present to you. So please welcome gentlemen from Facebook.
Well, good afternoon, everybody. Thank you very much for coming along. As Spaff said, stealing part of my introduction, my name is Mark Crosby, and with my colleagues For and Tim, we're going to give you a story of two halves about Facebook, our culture around security and how we do it, and then we're going to illustrate that with a constructive example of how we solved a real challenge, and that'll kind of show you how we approach security. As Spaff said, I'm a former Purdue alumnus. I graduated in '95. with a master's degree from here, and despite his best efforts, this has led me to working for Facebook today. So without further ado, what are we going to talk about? How do we protect 1 billion identities without losing too much sleep? If you think about it, Facebook as a company is tiny relative to the size of the user population. We have the data of over 1 billion people on our site, and yet we are a tiny company of only 5,000 people. How do we achieve that sense of scale while still allowing people to interact and for the site to evolve and grow and move quickly? And a large part of our security culture is built around that concept of getting out of the way, reducing friction, and making the right thing to do be the easy thing to do. One of the things that always amazes people is when they sit down and think of the scale of Facebook. It certainly amazed me when I joined a little over a year ago. I mean, most of us are used to thinking in terms of millions of things, but billions of people generating trillions of relationships between them, those are numbers that are really mind-boggling. Certainly when anyone ever talks about the number of servers and we get into hundreds of thousands, when we talk about logging data and we get into hundreds of petabytes, these are things where solutions that work in the small, which we define as for millions of people, just do not scale to the billions in sizes we deal with. The other key thing to realize about Facebook is it is a utility that people are coming back to time and time again. What we see is that these numbers are not just the total number of people registered on the site, but these are the total number of monthly active users. In other words, they've interacted with the site 29 out of the last 30 days, which is actually a fairly high degree of interactivity. 60% of them return daily, and on the mobile side, we see a 54% year-on-year growth. We've pivoted the company to be mobile first. You've probably begun to see a lot of this, much more coming up in your mobile news feed. We've actually finding most people are now interacting with the site via mobile. And yet we still have to support a huge variety of cultures all over the world, countries with many, many different national languages. And one of the things we deal with is a decision you make, and you think, I make this decision, it's a good one, you're making it often from a Western cultural context, and that is a decision that has absolutely no meaning to somebody on the other side of the world. And a large part of that is ensuring that we take that into account when we do security. So what's our charter, this group that you're looking at here? What team are we a part of? Now, one of the interesting things about the security team in Facebook is if you've looked at many other companies, we're not an IT security. We don't look at security as a networking problem or an IT problem. We see it as a more holistic problem. So the team is chartered with safeguarding the integrity of the graph. What does that mean? It's the social graph, the interrelationship between each of you and the people you're connected with, the things you like, the things you share. And that social graph is the lifeblood of the company. The integrity of it is critical to the success of Facebook, right? Makes sense. But we want to do this in a way that's meaningful. We don't want to just write security policies. We do not want to be a company that puts rules in the way of people. And we don't want to add what we call friction. Friction slows you down. If you've ever worked anywhere and you had to get approvals for something, you had to request something, you had to ask your manager for permission, and you had to sit there for days and days because the person who did that was on vacation, that's friction. We don't do that. So how do we do this? Well, I'm going to talk a little bit about it, and then the guys are going to give you some specific examples. A couple of pictures. We build data centers. We build our own, and the picture in the bottom right is a picture of our new data center in Sweden, a place called Luleå. It's about 100 kilometers from the Arctic Circle. It's the size of a couple of airport terminals, and will probably grow bigger. Our domain is very big and messy. We have hundreds of thousands of servers in a data center. We have network capacity that would boggle your mind. And yet, inside our company, people are free and able to do whatever they need to do to get their work done. How do we as a security team deal with the challenges of scale in a data center and yet freedom on our corporate network? That's one of the big things we deal with. The top left there, that's the population in the town of Luleå gathering on the ice. The river freezes over most of the year, and we're taking a big aerial picture of them, giving us a big thumbs up. The other thing is, while we have a very wide variety of kind of architectures and software and appliances on our corporate side, in our production side, we have pretty much open sourced our server design. You, if you were so bothered and you won the lottery, could go download the specs and build yourself your own Facebook data center. So it's all a fairly open design. But we think about security a bit differently. We don't want to put barriers in place. We don't want to talk about policies. We want to talk about real risk. And what we try and do is get the best people to design the solution. In a lot of companies I've worked for, the security team were seen as these wizards. They were off in their ivory tower. And every so often they emerge to make a pronouncement about a security policy or a piece of malware or a threat. Or they descended upon the product team to dispense their wisdom, saying, you are doing it wrong, no matter what you think. We're not like that. What we try and do is adopt a collaborative approach of working with other teams. You'll see that later when Tim and Ford talk as to how we rolled out this particular change, which on the face of it would make everybody's life difficult. But how did we achieve that without making their life difficult? And one of the key things is, as a global company, in the spotlight as we are, we're constantly under regulatory attention. So we want to exceed our obligations in those areas, not just meet them, but exceed them. That's one area that I'm very involved in. Certainly from a data protection, privacy perspective, one area where we do a lot of work in our team. So, feel free to jump in with questions at any point. There's no problem with questions, whatever they may be. I'm just going to go through now what we see as our top information security risks, and where does that lead us to in our design. I'm going to wrap up after about 15 minutes of talking and then turn it over to these guys who are far more interesting. Really, the core thing is the abuse of user data, that social graph. The single biggest threat would be if somehow someone maliciously tampered with your profile data, your pictures, your likes, whatever, in a way that we weren't aware of. Certainly followed by that is the release of your personal information, your user data, in a way that we did not control. Followed, not too far behind, but obviously our source code gets modified. If you're going to hack the graph, why not hack the source code to begin with? If you check in bad code, if you make some sort of malicious change, we won't be able to know about it. One of the things we take great pride in is our white hat program. And this is a program where security researchers who find bugs on our site submit them into our white hat address, and if we validate them as valid bugs and they're not duplicates, they get paid cash. The cash payouts range from just a couple of $100s to a couple of $1,000. There's one researcher who has made a six-figure salary off finding bugs on our website, quite a comfortable salary in the country he lives in. So we put our money where our mouth is when it comes to the protection of our source code. Obviously, we're concerned about our business data. This is an interesting one. We run ads on our website, you may have noticed. That's kind of how we generate revenue. And the way the ad system works is that there's a buyer exchange for this. There's the buyers of ads and sellers of ads compete to bid on an ad. And of course, people call up the sales team pretending to be buyers for ads and wanting a line of credit extended and then trying to grow that line of credit. They in turn sell these ads off. What we've been doing a lot of work on is closing down the risk of that fraud. And finally, us, the employees, our data gets compromised, we get targeted. And that ultimately leads us to looking at 4 areas of risk to the company. In our product, i.e. what we build. In the infrastructure, what we run it on. Third parties, people we deal with. And employees, the people we employ. After all, if I can't be trusted and I'm on the inside, we have a bigger problem. We spend a lot of time ensuring that people can do their job, but at the same time we know if they're abusing tools. Now, one of the interesting things about working for Facebook is you have a great big target on your back all of a sudden. Our employees are actually on the inside. They have access to a ton of information. Some of it they need to do their job. Most of it they'd never need to access. But what if they were coerced or strong-armed or compromised, either maliciously or without them even realizing? So Just by working for Facebook, we often have the challenge that people become targets themselves of phishing or other scams, which are the bad guys are basically trying to use the employees against us. So how do we deal with that? Well, we tend to take a very pragmatic approach to security. We could just glue thumbtacks onto the keyboards of everybody, and so to remind you when you're typing of what you're typing. But I tend to think you would find that that's not going to be a very good solution for very long. So how do we do this? What do we do to actually approach solving the problem? We want to be able to move fast. So when you need to request permission for stuff, we make it easy to do that. We don't want policies telling you what to do. We just want tools to let you get the job done. And one of the things that we find is because teams move so fast, we can never be a department of saying no. We have to be a department of saying, yes, you can do that, maybe just do it this way instead. So if you don't have access to things you need access to, we're going to find a way to make it happen so that you don't exceed your authority. Now, I've talked a bit about policies and I've talked about employees, and of course we're all familiar with awareness training, and yes, we'll do awareness training and all of our employees will be very, very up on security. Oh my goodness, that never works. I mean, the research shows that this does not work. You'll feel good about yourself and the people who are at the training will go, yay, you know, we got our metrics. But in the end of the day, the next morning, everyone's still going to log in with their password, that password with a 0. So what do? We try to make it a bit more fun. And what we do is we engage in playing games with the employees, and we do it the Facebook way. And so we try to simulate real-world attacks. We target our infrastructure, we target our employees. We have no losers. If you get hacked as part of this fun game we play, you win a t-shirt, you win a mug, you get stuff. And we call this Hacktober because we do it every October and it's Halloween themed. And people really look forward to this. It's gotten to the stage now in the company, this has become a real annual event for us. So for example, you know, people will be looking out for bizarre things showing up in their newsfeed, like finding a DVD with a load of design documents lying around, or you know, sketchy text messages appearing there saying, hey, try the new version of the Facebook mobile app. It's at fburl.com. You go, oh, okay. What you don't realize is the L's been rewritten to a 1 to fool you. A lot of people click on this, and of course the Hacktober pumpkin comes up laughing at them, and then they go get a t-shirt. Or the last one there, quite a common occurrence, a very sketchy request from a hot girl going, hey, I'm a hot girl, be my friend. We get this all the time. On LinkedIn, on friend requests on Facebook, and it's people trying to target our employees. And Charlotte here was quite wise to it and said you're totally compelling and not totally legitimate and very compelling. So with that, that's a very, very lightning fast introduction to our culture, how we think, how we do things. If there's no questions, if there's any questions, fire away, but if there's none, I'm going to hand over to my colleagues Tim and For. Any questions? Great. No, Joe, it's your guys.
Hey everyone, how's it going? My name is For, and along with Tim, we work on the security team, and Mark as well, at Facebook. And Mark talked a lot about the ways that we like to empower our engineers to move quickly, and yet at the same time, we want to maintain security for our internal data and our users. So what we wanted to do is talk to you about a specific example of that, of something we've recently done, and how we've taken that tension between being able to empower people to do their job quickly and also implement security. So we're going to talk a little bit about that. But before we get into that, I'll give you a little bit of background information first. So one of the things that, as Mark alluded to, is that at Facebook we actually get attacked quite often, right? So we constantly see attack attempts. It's a big target on our backs. So how do we think about these attacks, and how do we break it down into like a cognitive model, right? So one of the things that we use as this cognitive model is something called the kill chain. So the kill chain is breaking down the attacker behavior into a series of stages. And I think there's different works and literature on the subject, but we use the terminology kill chain for this. And basically the steps are broken down into a reconnaissance phase, setup of the infrastructure to do the attack, the delivery of the attack, the compromise that happens, the command and control network, a privilege escalation, lateral movement, maintaining persistence, and exfiltration. There's different literature that'll have slightly different labels or different stages in the chain, but the point is the same. One of the things that you can use as a cognitive model is use this kill chain as a way of modeling attacker behavior. So let's take an example of one of the stages in the chain, which is lateral movement. Now, by lateral movement, I mean that an attacker would compromise one of your machines of one of your employees, and then seek to try to find access to either higher level privileges or other machines within your inside your network. So one of the things we wanted to protect against was that kind of state, that part of the stage. So let's narrow down our focus on that stage, the lateral movement stage, and see if there's ways that we can improve security while still maintaining the high velocity that our engineers expect. So here's our engineers. Just kidding. They're obviously very good. They're experts, computer science people, and they want to be able to move fast. The other thing is they're ingenious, right? So the nice thing about that is they're very good at finding cool tricks and ways to do their job. The bad part is they're also very good at finding ways around security controls if they're in their way. So what we wanted to do is something Mark mentioned earlier, which is build a security control that made doing the right thing effortless, so that it was natural to do the secure thing. So let me tell you a little bit about what an engineer's workflow actually looks like. So you're an engineer, you're working at Facebook. One of the things that you'll do is you'll log into a development server to be able to write your code and do your work. All right. So we have thousands of engineers that work at the company, and obviously all of these engineers need to do these SSHing. Some engineers have a behavior where they log into these machines quite often. And in fact, we have tens of thousands of SSH sessions a day. And some users actually have more than 60 interactive sessions into these servers every day, individually, with over 3,000 non-interactive authentications. So, and what authentication methods do they use? So they use all sorts of things like passwords, public-private key pairs, and so on. So the dilemma was we wanted to make it so that there was a stronger form of authentication for engineers being able to log into these machines. But we also wanted to take in mind the fact that some engineers do this as many times as 60 times a day. So, so that was our goal, and sort of our value statement is how do we make this stronger, and how do we build the strong authentication that we built into the Facebook site in terms of multi-factor, we call it login approvals, that users like all of you guys can enjoy and turn on. How do we extend that model to support also this particular use case for our internal employees? Maintaining obviously the strong usability and cultural aspects that make our company so awesome. So we're going to go through, Tim's going to join you and talk a little bit about the state of multi-factor solutions in the industry.
Hi. So basically, like, the first thing we have to do when figuring out how to deploy a second factor is to, like, figure out what our options are, right? So, there's a lot of good options out there, but they all have, like, certain limitations. So if you take a look at time-based tokens, so like RSA tokens are a good example, or Facebook's code generator, there's kind of this security usability trade-off, right? So you have this window of acceptance, like 30 seconds is kind of standard, and so you can allow one authentication in that window, or you have to accept replays, right? So this is something that is actually like not all that awesome for an SSH use case, right? If you want to open two terminals at the same time or something, right? So we don't want to allow replays. There are there are some pluses to a time-based solution, though, right? So synchronization is easy. Basically, there's some key material and a clock, and both sides just need to have that, right? So you don't end up ever out of sync. And they also basically work everywhere. So like all you need to do is be able to input a number. The usability, though, right? So I talked about like once every 30 seconds. The other part is if I'm using Facebook Code Generator on my phone, right? Lift up my phone, unlock my phone, get my passcode, right? That takes me about 10 seconds. Chances are I'll fumble my PIN number on my phone a few times too, right? It gets annoying. So that's there's some usability downsides there. So the next option, right, is kind of an OTP-based one. So this is very similar to like a time-based one, except like you generate a password. So there's kind of there's a few types of these, but one type that's common is basically like a hot P technology, where basically you have some key material and then like a moving factor, a sequence number of some kind. The other kind is maybe like a challenge response thing, right? One of the downsides to having like a hot P style system is you end up with out of sync errors. So basically, like imagine you have a token in your pocket with your keys, and you start walking, and every time you move your leg, your keys bump the button on your token and advance the counter, right? So when you get like, you walk 500 steps, you advance your token 500 places, like you're out of sync, you can't log in anymore, right? And so that's kind of a usability fail. There's methods for like resequencing them, but like super not user friendly, right? Also, these tokens are also kind of designed for infrequent use. So they're good for like VPNs and stuff, right? Where like you pull it out, you use it like for to authenticate for that one session that's very long lived. But they're not good where you're opening multiple SSH sessions, where like you basically have to type in your 8-digit code like 10 times if you wanted to open 10 SSH sessions. But like the time-based tokens, they have generally good interoperability, right? All you have to do is be able to type in a number with your password, so or without your other auth method. So biometrics are yeah. So this is a fun option, right? But like there's extremely limited support on for various devices. So for example, like Mac laptops have no form of biometrics built into them. Most laptops don't, right? We're only now like this week seeing the introduction of first biometrics for phone, right? So this is something that like it just isn't available. So and if it were, we'd have to give our employees something giant like this, right? And like I don't think any of our employees will be happy like scanning their eye, right? There's also some security problems with biometrics. So like there's been a lot of researchers who found like false acceptance rates, right? There's replay problems with this. And then there's some practical problems. Like what we want to do is figure out how to use a second factor to authenticate your SSH session remotely. So how do you use a biometric factor on that remote server when when you're local to your laptop, right? So it doesn't quite work out for us. Let's see. So PKI-based stuff, smart cards are kind of like the next available option. This also has, generally has poor device support. So like, how do I hook a smart card up to my iPhone, right? Or if I wanted to hook a smart card up to my laptop, I'd either have to carry around a giant reader or some USB device, right? There's also some interesting problems with smart cards. Like I think it was a couple years back, Mandiant coined the term smart card proxy attack, right? And so this is basically like you can intercept, the way smart cards work is like you generally insert your smart card, you type a pin on your computer, right? And so a remote attacker can actually intercept that and then use your smart card without your knowledge, depending on how your smart card's set up, right? And so that's kind of a security problem in some respects. And there's actually been attacks in the wild that have been seen doing this. So it's one of those things that we want to avoid. There's also other problems with smart cards and PKI infrastructure in general. Like for smart cards, management is a giant pain. So generally you have to like every vendor has their own specific middleware. There's like always kind of conflicts. Like if you want to run across multiple platforms like Mac, Windows, Linux, it just doesn't work right? Your smart cards might have to be formatted different for each of those systems, and your users end up having a lot of pain, basically just overhead to have the smart card. So the last option is basically like an out-of-band second factor. So an example of this is like getting a text message, right? So Facebook uses this. So there's a lot of services that do text messages for your second factor. This is kind of a really easy to set up, easy to use solution, right? But it requires a reliable out-of-band channel. So SMS not reliable everywhere, right? So there's also the other out-of-band option is push, which is awesome for those of us who have smartphones. But again, it requires reliable channel, requires awesome smartphone, right? That sets up that can accept it. This also requires internet access or cell access on your phone. You might not always have wireless access where you have an Ethernet plug and want to use your connection, right? This also has the property of usability for like a good usability for infrequent use only. You don't want to be receiving 20 text messages to open up 20 sessions, right? You want a long-lived session. So also all of these options, one of the big downsides too is basically you have to carry a second device with you, right? And people lose their keys, they lose their phones, they lose whatever their second factor is. That's going to happen all the time, right? So there's going to be a lot of overhead in terms of like basically just help desk trying to fix all of this. So basically we end up with Michaela not being very impressed, right? Like all these solutions, like they kind of have good aspects, but none of them by themselves really work all that well for our specific use case of trying to authenticate frequent logins, right? So Forrest's going to kind of talk about what we did to make it better.
Right. So Tim said, there's a lot of problems with some of the existing solutions, and we needed to come up with something that would help us improve the security, but also allow people to move fast. So what did we do, and how do we combine these things that exist in the world to make it so that we would have something that would work for us? So just to review, we wanted something that would be ultimately usable, Again, supporting very frequent use. That was one of the biggest downsides of the solutions mentioned. Usability for us is a really important factor. I keep harping on this, and I know it's kind of, I'm overstating it maybe a little bit, but our company really is focused on moving fast, and usability is really a fundamental tenet of our company. We also wanted people to be able to have flexible options. So if they're in a region where out-of-band stuff doesn't work so well for them, maybe they could have a different option. And so also the security model needed to be strong. And also we needed to be able to roll it out relatively quickly and also not have to spend a lot of time supporting it once it was rolled out. So what do we do? Drum roll. So we actually implemented a combination of solutions. So the first thing we implemented was from a company called Duo Security, which is a really awesome company that's done a lot of really great work on pushing forward usability and pushing the usability envelope for authentication. So the way Duo works is it's a option to install on your phone as an app, and it supports a multitude of authentications mechanisms. So it supports push notifications, SMS delivery. It supports things like voice calling. So if you can only get a phone call at your home phone or something like that, it even supports that. It's extremely flexible. But the issue we had with Duo was only one thing, which is that it gave us a lot of flexibility and a lot of powerful options, but it also the ultimate solution for it was the push notifications, which was also worked for many of our users, but not quite fast enough for some of our most aggressive authenticators. So we combined it with something called the YubiKey Nano, which is a solution built by a company called Yubico. And you can actually see the token on the right-hand side, as well as it's in the laptop here, which I'll show you at the end of the talk. It actually fits snugly inside your USB port with only the slight flange of it sitting outside. It actually works as an OTP token, and all you have to do is press the side of the token and you're authenticated into your server. And so for people that were logging in a lot to their SSH system, we actually paired these two solutions together such that all you had to do was press the side of your laptop and you're in your dev server. You're in your server you're trying to get into. But if you're also traveling or you lose your device or you have other reasons why you want to use different mechanisms, you actually have the flexibility to fall back on things like push notifications or voice calls and so on. So we're really happy with this solution, but we actually ran into all kinds of issues in planning the solution. So Tim's going to talk a little bit about the actual mechanics of rolling this out and the kinds of interesting and weird, strange corner cases we found when doing so.
Yeah, so we found this, we came up with the idea for this awesome solution, right? But like basically how do you do it, right? So as For kind of mentioned, earlier about how our development environment works, like we have engineers SSHing in, a lot, right? Some of them do like extraordinarily frequent logins obviously from non-interactive things if they're doing thousands per day, right? Some of them do a lot of interactive logins. They use every single authentication mechanism SSH allows, right? And so, this in particular causes some interesting issues, right? Like, so first of all, we actually have to understand how people are using our SSH stuff. So we can look at our logs, and what do SSH logs tell us? Well, they tell us that we have all these logins, and the numbers actually don't really help us that much, right? What we actually want to know is what people are doing with their logins. We actually, there's kind of two problems in this, right? The first problem is figuring out what was done with the SSH logs. And then it turns out the second problem is, like, how do we analyze that data? So if you look at like an SSH log, right, it tells you who logs in. So the first thing we wanted to do was figure out if someone's running a shell or running a SFTP or running a command with their SSH, right? And so, like, this data is kind of all there, but it's not there like the command that you ran with your SSH isn't actually in the log. So we basically had to extend the SSH logging to log a little more detail about what was happening, right? The next thing we had to do was start analyzing that. And so SSH logs are interesting because like not all the information is on every line, right? So you have on the first line you would have like a user logged in, and then on the last line if you're running a command it would be the command that was run. And then you want to figure out, like, first of all, like what SSH client ran that, what user ran that command, right? And you'd have to kind of combine them all. So of course these are syslogs, right? So we can sessionize them by like the process name and the PID, except not, right? Because the PID can change even during that one login session, right? The child is going to have a different process that actually runs the command. So we actually had to build in session, like build in some extra data that allowed us to uniquely identify an SSH session, basically, so that we could sessionize it and do analysis over the SSH stuff. So this was kind of like this was actually a big deal because we have, like as aforementioned, we have a lot of SSH logins, right? And so what we found is that people were running all kinds of interesting third-party software, right, as their SSH client. So not everyone was using OpenSSH as a client. The other thing was people had a lot of custom scripts that they were using to log in. And then, let's see, the third thing was people were using SFTP a lot, right? And so the reason why these use cases are interesting is because if you look at scripts, right, generally scripts are run non-interactively. And so you actually want to support that functionality without having to have someone auth. Actually, I think I'm getting ahead of myself. Let me back up a little bit. There's also the problem of how do you do the multi-factor authentication in SSH, right? If you look at how SSH logins work, how you generally do multi-factor, right? You'd actually do it in the PAM stack where you can actually just prompt for multiple authentication methods or something. The problem is if we did that, we'd have to only use passwords. And passwords actually are something that add friction for our users, right? So some users who are maybe infrequent users, they don't mind, they type in their password, right? And then they'll go. But most of our users actually want to use either Kerberos or SSH certificates or SSH keys, right, to log in. So, like, basically, how do you marry that with the second factor? And so, actually, this was kind of made possible in it was OpenSSH, I think 6 or 6.1 or something, where they actually introduced a mechanism to do the multi-factor authentication within SSH. You could specify multiple authentication methods. However, that didn't actually quite work directly for us because you would still, if you ended up hitting the interactive method, you would actually have to require a password and a two-factor if you wanted to accept both password and two-factor as an option in addition to the other ones. There's like minor technical details that you run into, right, when doing the implementation. So what we actually did was with the help of Duo, we actually wrote like a separate keyboard interactive drivers, and like, so this is actually now in current version of OpenSSH, you can actually, easily sub in what subsystem you want to take an input from. So we can actually say, take your input from a password or take your info from Duo and stuff. And so with the help of Duo, we actually have some custom modules that do that as well. So anyway, so now we have the two-factor, the ability to log in with two-factor, right? But then going back to like the scripts and SFTP and stuff, it turns out that a lot of people have non-interactive usage. So scripts, there's actually only, thankfully, a handful of them, right? So what we actually did was tried to come up with a solution to run scripts, non-interactive scripts safely without a second factor. So basically the idea is like, if you can define a small set of stuff, of activity that's safe, you can, like, then you don't actually need two-factor for everything, right? So we actually spun up a separate, another SSH on a different port that actually just had a whitelist of commands. So this introduces another problem of like, now you're whitelisting certain commands that can run non-interactively. First of all, like, how do you make sure they don't do dangerous things? How do you make sure that you're avoiding actual vulns in your whitelisting scripts that handle all that kind of stuff, right? So that's its own talk actually. The next thing was SFTP. So people, like, there's a lot of people who use SFTP clients, like the command line, right? SFTP OpenSSH client, and that works fine. But basically, there's a ton of third-party SFTP clients that just don't work. And so what I mean by don't work is, like, basically every single third-party software, and by third-party I mean SSH software that's not OpenSSH, not part of OpenSSH, right? They basically don't understand how to do a multi-factor auth, right? You have your options in the menus for authentication. You have password, or you have certificate, or public key or something, right? And basically that's it. So we actually had to find a workaround to allow SFTP access because a lot of developers needed this. So what we did was we spun up on yet another port, a non-interactive SFTP only session that provided a CH-rooted environment to a lot of the data. So what we actually wanted to avoid was things like a single factor login that allowed you to write to your .bashrc or something, right? So that allowed you to execute commands effectively with only a single factor. So we did basically a bunch of work to figure out how to set up that environment properly, and so it's worked out pretty well for our developers. So once we had all this kind of figured out, we went and beta tested it. Everyone basically was happy. We minor fixes on the edge case, right? And so then we decided to do, it was time to do our larger rollout. There were some kind of painful, unexpected issues when we did the larger rollout. The first thing that we ran into was different keyboard layouts. So the YubiKey, this actual, the text at the top of this Insanity Wolf meme is actually a YubiKey OTP. So a long string, right? Those work on QWERTY keyboards. They work on a handful of other layouts. They don't work on Dvorak. So turns out we have Dvorak users. Who knew, right? So then we had to scramble for that. And then it turns out it doesn't work on Colmac either, right? And so, and I had never heard of Colmac until we ran into people who apparently use it. So what we did for that was we basically decided that for some class of users, we couldn't use the this YubiKey token is OTP is actually using the YubiKey AES algorithm. It's actually has some properties that are a lot nicer than HotP. But we actually switched to using HotP for the users with Dvorak and Colmac keyboard layouts, right? And so that is a 8-digit thing. So the numeric numbers are the same. Like the scan codes for those are the same on nearly all keyboard layouts, except for programmer Dvorak, which I had never heard of before either. But yeah, those are all the special keys that you'd want for programming, not numbers. So that so there was some fun issues dealing with that and trying to help people debug what was wrong remotely when they didn't know to tell you that their keyboard layout was a problem, right? So the next problem we had was we call it exploding computers. So this is kind of a very unexpected and very sad issue for us. So one of our users accidentally put in his token backwards and upside down. So these tokens, they're very small nubs that sit very flush in the computer. If you really don't pay attention that much to it, it's pretty easy, and it's a little tight to force in backwards and upside down, but you can do it. And so what happened was shorted out machine, it like completely fried it, right? And it turns out this was a larger problem than just one person. It turned out like we had multiple people doing this. Now, most of the time, it just caused the computer to reboot. But there was a handful of cases where it just like completely fried the machine. So that's kind of a very depressing thing that we didn't anticipate. There's also SSH client config problems. So it turns out that basically we were relying server side on the clients being very accepting of the options that we required on the server. It turns out that most people on their SSH client, or not most people, but very many people, for whatever reason, put very restrictive SSH client configs. There might have been some like old documentation that they just copy and pasted into their SSH config file, and that basically broke logins. And the fun part about that is, generally speaking, people don't really understand what's going on when they SSH the systems, right? Like maybe if you're into security and you try and like understand everything that's going on, it's fine. But like normal engineers, the SSH is just a tool for them. They use it, it works, right? And so when it starts breaking, it just says the error message is fantastic, right? It just says authentication failed. And so then you have to kind of go through with people and walk through what the problem is, and so that takes a lot of support cost, right? Let's see. Weird SSH client behavior is actually another really fun issue that we ran into. So there's a lot of clients that, like I mentioned, I think before, that not all clients actually support the multi-factor prompting, right? But some clients, like, they seem to support it. They'll actually prompt you for a password, or like they'll somehow do like a SSH key auth and then prompt you for a password, and then people are just putting in their OTPs in that, right? But the interesting thing is the failure condition of a lot of these clients was such that they basically like replayed that token over and over if the network got disconnected and it tried to reauth, right? Even if you said don't save password or something, it would still, that would mean don't save password between different instances of this SSH client, right? Not don't save passwords like at all. So we ended up with a lot of people who replayed their tokens over and over and got locked out, and then there's a notification on that. It also turns into authentication failed SSH login message, right? So very, very difficult to actually kind of figure out root cause on this, right? You'd have to go and kind of understand how all the different auth layers work. And the last kind of fun issue that we had was, so there's because of the YubiKey being like so usable, people accidentally spat out too many tokens. Basically, they would accidentally press it, and they would end up with like posting Facebook posts with their YubiKey password in it, and so with their YubiKey token and on IRC and whatever, right? And so basically, we ended up with a whole, this is actually kind of a positive thing. People, like, it became a meme, basically, within the company, right? People kind of thought it was extraordinarily amusing that we came up with a solution that was so usable, like they used it when they didn't intend to, right? So that's I think that's kind of it. So that kind of covers everything we kind of went through in the rollout. There's actually a bunch of future work that I don't think I'll talk about, but like basically this kind of solves just the use case of SSH, right? But the interesting thing is, like, this isn't like universally applicable to all of our other multi-factor issues, right? Or internal authentication issues where we might want multi-factor. So there's still a lot of work to do on improving usability on different layers of the stack. So, anyway, that's all.
I mean, I'll just wrap up then. I mean, basically, this is a practical example of sort of the cultural stuff I talked about at the start, where we said to ourselves, hey, we've got a problem, and the traditional solution looks like smart card or OTP tokens. Right, everybody else would have just jumped on that and said, hey, that's what you're doing. I don't care if you have 30 logins, deal with it. We said, no, there's got to be a better way. And it was very interesting to see how we iterated through all of the evaluation, and each of them just kept falling down. And ultimately what came together was a combination of two solutions. And even then, as the guys showed, the corner cases that come out, there's always weirdos in a company, but how we actually dealt with that in a constructive way, rather than saying, no, tough luck, Dvorak keyboards are too weird, get with the program. We actually said, hey, let's figure out how to make this easier, because this person has got to get their job done, and our job is not to get in their way. And in the end of the day, I'll pull out the YubiKey and show you, assuming it doesn't make my laptop explode, and there we go, it already did. A YubiKey is ultimately just a small little piece of, too small it turns out, a small little piece of...
One of the nice features is that it's not easy to remove.
Of metal that sticks out. You literally, when you log in, you rub it, and off you go. And it is the easiest thing in the world to use. So I think we'll wrap up there. Thank you very much for your time and attention, and we're happy to answer questions now, or comments, or jokes, if you have them. Yes, sir.
So it's very interesting. So I wonder, how do you know whether it's a success, whether it's worthwhile to do this? So what is the threat sort of before deploying two-factor authentication?
So I guess we probably didn't cover this in too much detail. Basically, like part of the I don't know. Actually, do you want to talk about this in terms of kill chain and the threat?
Yeah, sure, I can. Yeah, it's a really good question. So why was this motivated, right? So one of the things that we worry a lot about is our, we give our engineers and the people that work at the company a lot of access to their own systems because of the fact that we want them to be able to get their job done. And one of the things we worry about in terms of the kill chain is a client compromise, a user compromise, right? That would then in turn lead to access to internal systems, right? We talked about in the beginning of the talk this notion of lateral movement, right? So this was really motivated by a lot of the attacks we've seen, we've worked on in the past in our lives, and we've seen attackers engage in this behavior where they will compromise a client machine and then move into things that you care about, places that are sensitive. And so this was really a place to make a barrier to try to mitigate that lateral movement into those systems that we were trying to protect. Does that make sense?
Yeah, I mean, basically, like most companies, we have like other multi-factor, like at our edge, for example, on VPNs, right? But internally, it's been something that it gets in the way. It's generally an item that you don't want to do because it is painful to use because of the usability issues I discussed, right? So it was kind of one of those things that ended up being a point of where there was easy lateral movement without it.
So that key is always there, but only when it's pressed is actually enable authentication.
Yeah, And so,
Yeah, it actually acts like a keyboard device, and so when you press it, it actually types like a keyboard. So that's how it works.
yeah, and so the idea is that we have a high confidence of user presence then, right? So our threat that we really care about is remote attacker in this case. And so it works out.
Any other questions? As a reminder, if you're asking a question, just to turn your microphone on in front of you so the others outside can hear. Yes, sir.
In situations where Facebook takes open source projects and extends them to meet certain production needs, what additional precautions do you take in terms of evaluating and improving the source code?
So basically, let's see. So basically, we just have a code review process, right? So there's always basically two engineers who have their eyes on the code. We are very selective about who reviews it. So like, I'm not going to choose someone to review a change to an internal change to OpenSSH who doesn't do any C programming, right, or doesn't understand Unix systems, right? So that's basically it. We get a couple eyes on it. We also are very careful with deployment. Obviously, like when we change something that's so widely used, there's a big risk of breaking it, right? So.
Any more questions? Okay, so thank you for that and attending. We have a student social mixer now at 5:30, so in about 14 minutes' time. It's in the CERIAS building in the conference center upstairs, just by the main entrance.
Recitation 218.
Recitation 218. Myself, Four, and Tim will be there. It's a very informal meet and greet, a bit of free pizza too, which always goes down well. And if you have questions you wanted to ask but not in a group, want to talk to us one-on-one, or just want some advice about your career, what direction to take, how did we get to where we are in life, and how can you avoid making the same mistakes, that is the time to meet us. Thank you very much.